Hello, I'm Otakar from Certora, and in this video, I'm gonna go over all the specs that we have for the silo code that you can use in the contest. I'm just gonna talk about the formal verification specifications, not about the code itself. Okay, so this is the contest repo, and all the formal verification things are in the Certora folder. So we'll just go one by one, starting with the mocks and harnesses. So these folders actually hold the objects, the contracts that we use. So the silo, when it's deployed, there are actually two silos together with the silo config and a lot of other stuff around, like the token pair that we want to exchange. And each silo also has collateral token, protected share token, dead share token, and stuff. So for each of these contracts, we have a dummy implementation, like the silo 0 and silo 1. These are actually the same code, but we need two different contracts so that they don't share storage and everything. So we have a dummy implementation for all these, and it's here in the harness. And also in the mocks, we have the tokens and an empty hook receiver. Yeah, which we also need. We just use the empty one most of the time. Okay, now let's see the specs folder. Here are all the rules we have, the simplifications that we've been using, and also the setup. So maybe let's start with the simplifications. So the silo code is very complex and quite large. There are a lot of contracts and a lot of hard math involved. So in order to actually be able to verify something in a reasonable time, we found out that we need to simplify some methods. And these are the methods that we used often during the verification. You might use either of them, you might not use them if you don't need, but they are there. So just so that you know. For example, no, the Oracle Quote 1 is it simplifies the quote method uh, with price is 1, meaning giving the some amount of token 1, and we are asking about the price of these tokens. We just return the same amount, meaning that the price is always 1. All of these files are marked either safe or unsafe. Unsafe means that we are actually missing some execution paths if we use them. So here, obviously, we are missing the executions where the price is not 1. But usually we have a good reason to believe that this is good enough. Like if the bug is present in the code, it would manifest it with the price 1 already. So we don't really need to use the other execution path. Like from the formal perspective, it is unsafe though. So yeah, we mark it as such. And there are more. This is like a more complex, some simplification where we use 3 different prices instead of just one. We have a summary for the is solvent method, which is also hard. We have actually 2 different summaries, I think. So yeah, it's up to you to use whatever from here that you find useful. By default, we don't use anything. If you want to use it, you need to specifically import it. Like here, for example, is some spec file. Okay, this one does not use anything. Let's see this one. So this one, for example, uses the simplified get compound interest rate simplification. Okay, we have um, we have a lot more here. There is the silo math lib, which I recommend using, which summarizes the convert asset to share, convert to assets, and convert to shares. These are hard methods that are being called very often, and we have a very good axiomatization for them. So we might want to use these whenever possible. Get compound, the solvency. Yeah, so it's up to you to decide whether you want to use them or not. For the properties that actually do not talk about solvency, you might want to use like very hard summary for the is solvent method. For the properties that actually wants to prove something about the solvency of users, you don't want to use the summary, right? You need to use the exact uh, implementation. Okay. Uh, let's talk about the setup now. So the setup, it's quite, there are a lot of files here. Um, might be a little bit confusing. So I have a diagram here that might help understand. So the purpose of the setup is to actually tell the prover how the contracts interact, like what contracts are there and how they interact. If I have silo 0 and silo 1, and there is a silo config, for example, and if I call something like silo config get other silo, and I pass silo 0 there, then the return value needs to be silo 1. And it actually links the return value to the DAM to the dummy contract implementations that I was talking before. And it does these kind of linkings for all important methods on the config mostly, but also on the other contracts. Uh, right. So this is what it looks like. These are the files, and the arrow indicates that one file imports another file. We actually have two different setups. One would be for what we call single silo setup. That's the lower part here. And the other would be two silo setup, which is the upper part. So the pattern that I've been using here is that, for example, let's see single silo method as an example. Here I have some stuff for silo 0, like these usings of the relevant tokens, maybe some methods being declared as and free and other thing. And in the two silo setup, I import the original file and I add the same thing also for the other silo. So for the two silo setup, I import the single silo stuff and add the same also for silo 1 and the relevant tokens 1 and the same methods. And the same goes for everything else. So yeah, the question is, why do we want to have two different setups? And the reason is that the complete two silo setup is quite complex. And sometimes for some properties, we don't really need two silo setup. Some properties do not care about the other silo. They can be proven when only considering a single silo. So for these, you might want to use the single silo setup. For most of the properties, actually, you need the two silo setup. And to make this user-friendly, there is a complete silo setup.spec file, which actually imports everything recursively. And inside that, there are methods called safe assumptions. There are several of these safe assumptions with invariants or without invariants, with environment only or with environment and the user, and even for a specific method. So what these do, they make sure that the initial state is actually valid. So when proving properties, we need to start in a valid state. Otherwise, we start an invalid, we end up in invalid also, which would violate most of the properties. So yeah, we need to start in the valid state, and this is the way to do it. So how you can use this? Here's an example. You can just import the complete silo setup, and that's it. And at the beginning of the rule, you just call safe assumptions. You choose whatever method works for you. And for example, this one involves an address, some user, and it will require invariants. Let's see an example here. I'm not gonna go through everything thoroughly, but let's just see. Right. So these are the invariants that it's gonna require token distribution. Let's see what it is. Yeah, it says that token 0 total supply must always be greater than storage of the protected collateral and balance of the users, stuff like that. These are like straightforward, but if you don't tell the prover that they currently hold, it might not assume they hold, and they might cause all kinds of problems like overflows in unchecked blocks and stuff like spurious country examples. Yeah, so you need these in most of the rules. Uh, yeah, so that's like super user friendly. You just import the file and call the method. You don't really need to delve too deep into that. I'd say you can, of course, if you want to. Yeah, it should work for you. Okay, that's the setup. And let's see. Okay, let's see some rules. I've already shown some, so like the max correctness, it's nothing too surprising, I think. You import typically, of course, you can work whatever works for you, can do whatever works for you, but what we typically do, we import the setup, we import the simplifications that we need. Uh, you don't often need all of them. It depends on the type of properties. And then we write either rules or invariants, typically starting with the safe assumptions, asserting something. In Sometimes you don't need to call the safe assumptions. You can just, if you don't need all the valid state requirements, but just some of them, like these things here, timestamp is greater than last interest rate timestamp, and stuff like that. So sometimes you only need parts of the setup, so you can just call the thing you need. If you want all, you call the safe assumptions method. So yeah, nothing too surprising here, I hope. Um, yeah, same for the liquidation. You just has rules for the liquidation. Mm, let's take a look at the conf files for a sec. So the conf files are those that you actually run. There are the files involved. Um, there are linking is done. You should not need to touch these. Maybe you don't need to touch the conf file at all, just so that you know what's there. I recommend using the build cache. It might speed up things. Global timeout, this is very high. Maybe you want to start with something lower. I recommend using the sanity, although in the end, you might want to turn that off because it takes some time and the runs here in Silo are already quite long. You should not need this. Like you can play with it a little bit. The loop iter should not be important here because they don't have any loops. Parametric contracts are important. This tells you which methods, which contracts are gonna be like called methods on. So when you prove something, saying like something hold, assuming that a property X holds now, it will also hold after any public method call on silo 0. But you might also want to prove that it holds after public methods on the tokens, like on the shared token and the share protected, and also on the tokens. Yeah, so that's pretty much it. Um, Here in the partial liquidation, there are two more things here, which you don't need to pay too much attention. This is just to get rid of a problem. If you get an expanded to too many commands error, then this is the solution. You increase this limit here, and the same for too many blocks. You just increase this limit here so that you know it can happen. It happens with Sile. It's quite large. Okay, so there's that, and there are the properties draft MD, which I recommend looking at. So these are the properties that are supposed to hold in the system. We did not write rules for all of them, so you might, if you don't know where to start, what properties to write, this is a good start. Some of these properties actually require you to use hooks. We already have hooks here, so you might want to use the files that we already have, like accrue hooks, for example. Yeah, so hook is something. If I hook on token zero balances, it means that whenever this storage changes, this code, the hook triggers. So this code gets executed and the ghost, for example, in this case, gets updated. And I can then write rules about these ghosts. Yeah, so if you need to use hooks, you might, in any case, I think you should check the existing spec files because they have a lot of infrastructure already there that might be useful, like these definitions and stuff. Right. Yeah, so that's pretty much it. As I said, the silo is quite complex, so there might be some problems. What I remember, we had several issues. Like there are methods called call call on behalf call on behalf of something which we usually discard in parametric rules because these are like a godlike admin methods that can do anything, so they can typically violate any property if called like wrongly, but we just need to assume that the admin will not do that. So that's one thing. Uh, yeah, and the simpler rules you have, the better, because the runtimes might already be quite quite long in this here. Okay, I think that's that. If you have any questions, feel free to reach out. I ask either on Discord or via other channel. We are here for you. We will help you in any way we can. And I hope you enjoy working on the contest and that you verify many interesting rules. Thanks for listening.